Hello everyone, welcome back to the course Power System Operation and Control. In this video, we will take an overview of Power System Control. Power System Control is nothing but to control the parameters which are very basic to the power system. As all we know that voltage, frequency, these are the very basic parameters. Even we can take into the consideration the reactive power as well. So once these parameters are at the rated values, the system can perform all the operation at the rated parameters or rated values. Therefore, it is very essential to control all these basic parameters to have appropriate operation of the power system. Now, in the power system control, it includes speed regulation of governor, where the speed is been controlled with the help of governor. This is at the time of generation. Then controls the boiler pressure, temperature and flows. These are also responsible parameters to control the speed of the alternator. Then speed regulation concerned with the steam input to the turbine. As we are going to increase the steam input to the turbine, speed is going to increase and proportionately frequency is going to increase. Therefore, it is necessary to regulate the speed of the alternator. Load is inversely proportional to the speed, as all we know that when load on the system is going to increase, the speed of the alternator or the electrical generator is going to reduce. Therefore, whenever there is excessive load onto the generator or alternator, the speed of the alternator is going to reduce, and to have the rated frequency or power frequency at that point of time, it needs us to increase the steam input or fuel input to the turbine, by which we can have the rated value of the frequency. Then governor senses the speed and gives command signal, and steam input changed relative to the load requirement. Let's see one by one. As far as governor is concerned, it is a device used to control the speed of the prime mover. A governor protects the prime mover from overspeed and keeps the prime mover speed at near to the desired RPM. So therefore, from these two sentences, it is very clear that a governor is a component or a device used to control the speed of the prime mover. With the help of governor, we can protect the prime mover from the overspeeding, and we can keep the prime mover speed at or near to the desired RPM. When the prime mover drives an alternator supplying electrical power at a given frequency, a governor must be used to hold the prime mover at the speed that will yield this frequency. An unloaded diesel engine will fly to pieces unless it under governor control. So it is very essential control in the generating unit or generating station to control the speed of the prime mover, because prime mover is mechanically coupled with the rotor of the alternator. So the prime mover speed is quite important as far as frequency of the generated electricity is concerned. Then we'll proceed for the load frequency control. So as we have discussed, when the load onto the system is going to increase, speed of the alternator is going to reduce, and as a result of that, the frequency is going to reduce. So therefore, whenever there is an increase in load, it needs to be sensed by the appropriate system, by which we can increase the fuel intake or fuel input to the turbine, by which we can maintain the rated speed of the turbine. Load frequency control senses the bus frequency and power frequency. It is a kind of closed loop system where bus bar frequency is also sensed and the power frequency is also sensed, and the values are being compared, the difference fed to the integrator and speed changer. So if there is any difference in between the bus bar frequency and the power frequency, it will be sensed and it will be sent to the speed changer. The speed changer is what the mechanism which will increase or decrease the speed by changing the fuel intake to the turbine with the help of appropriate mechanism. Time and frequency maintained at constant. So this is what the necessary, or this is what the prime requirement of the any electrical system, to maintain the tile and frequency at a constant values. Then after load frequency control, we will move towards the economic dispatch control. So unless and until we won't have the economic dispatch, we cannot have appropriate sharing of the power amongst the unit and the load. When the load distribution between number of generator units considered optimum schedule affected when increase at one replaces a decrease at other. Optimum use of generators at each station at various load is known as economic dispatch control. So to have the appropriate or optimum dispatch from the different generating units to the load, it needs to have a mechanism by which we can, as a system, we can deliver the electrical power to the load at the minimum cost, as well as it won't have any kind of impact onto the system. And one important aspect is, with the help of such kind of control mechanisms, we can able to have the appropriate continuity of the system by which load will not get affected. Automatic voltage regulator is a kind of regulator which will control the voltage by controlling the excitation of alternator. It regulates generator voltage and output power. The terminal voltage and reactor power is also made. So unless and until we are not going to control the excitation of the alternator, we cannot able to control the terminal voltage of the alternator. So therefore, to control the terminal voltage of the alternator, it needs us to regulate the excitation of the alternator. So by having appropriate mechanism for automatic voltage regulator, uh, we can change the excitation, and by changing the excitation, we can regulate the voltage of the alternator. Then system voltage control. In the system for voltage control, we have different devices and mechanisms by which we can control the reactive power of the system, and as a result of that, the voltage will be get controlled, and we can have the rated values of the voltage throughout the system. So this can be achieved with the help of static bar compensators, synchronous condensers, tap changing transformers, switches, capacitors, reactors. So with the help of all these devices, we can control or regulate the voltage within tolerable limits or prescribed values of the voltages. Then it comes the part of security control. So in this, the system first, it will be monitored. Then as depending on the state of the power system, that is, we have different states of the power system: normal state of the power system, abnormal state, emergency state. Likewise, we having different states of the power system. So these states will be known after the monitoring of the system, and depending on the monitoring, the decision will be taken, and on that decision, appropriate control action will be taken. So it is a part of a security of the power system by which we can avoid different sorts of blackouts in the system, which are very harmful as far as power system is concerned. Then monitoring and decision. Condition of the system continuously observed in the control centers by relays. So with the help of relays, different parameters are continuously monitored and observed. And based on the signals given by the relays, the protective system will come into the picture, and it will protect the different sections of the power system. If any continuous severe problem occurs is in abnormal condition. So if system is having a severe problem, then that will be also sensed and that will be also curtailed, or that will be also eliminated from the system, by which we can maintain the healthiness of the system, as well we can have the continuity of the entire system. For the control, it requires to have a proper commands which are generated for correcting the abnormality in the protecting the power system. If no abnormality is observed, then the normal operation proceeds for the next interval. The central control are used to monitor the interconnected areas. Interconnected areas can be tolerated larger load changes with smaller frequency deviations. So to have a convenience in the operation as well as to fulfill the demands of the loads, as all we know that we have interconnected systems. So in India, if we take into the consideration, we have different regions. So all these regions are connected all together, and which forms a national grid. So in this, as all regional areas are interconnected, so if any load changes are there with one area or region, that can be tolerated or that can be managed with the help of the other areas, by which we can able to control the frequency deviation within the smaller value of the frequency deviation. Central control centers monitors the information about the frequency, generating unit outputs and the tie line power flows to interconnected areas. So the central load dispatch center or even the regional load dispatch centers are continuously going to monitor the generating unit outputs at a particular instant, as well as the loads at that instant and the tie line power flows. This is just because if any increase or decrease of the demand is there in the system, so that can be managed without hampering the basic parameters like voltage and the frequency. This information is used by automation load frequency control in order to maintain the area frequency at its scheduled value. So this is all about the control. Once again, we will take an overview of the control. There are different controls are available in the entire power system at different stages or at the different sections of the power system, by which we can control the different sections as well as we can control the entire power system. So the different control actions or mechanisms in the power system are in the generation stage. We have the speed regulation, that is with the help of governor we can vary the fuel intake into the turbine, and with the help of that we can able to control the speed of the alternator or the generator, by which we can maintain the rated RPM of the prime mover as well the rotor of the alternator, by which we can maintain the frequency at its rated value. Then in the generating stage itself, we have the control for the boiler pressure, temperature and flows of the fuel. Speed regulation concerned with the steam input to the turbine. So almost first three controls are coming under the generation stage. So speed will be regulated with the help of different mechanisms and the parameters, because it will directly impact onto the frequency as well the voltage of the alternator, which is the most important part of the power system. Then, as all we know that load is inversely proportional to the speed, therefore it requires to regulate the load, or not to regulate the load but to regulate the sort of generation. So if we have, or if it is not possible, then it is required to regulate the load as well. Therefore at all the time it needs us to generate the power which will be equal to losses plus load of the system, by which we can maintain the basic parameters, that is frequency and the voltage in the prescribed limit. If load is going to increase, the frequency is going to reduce and speed is going to reduce. Therefore, to maintain the rated value of the frequency, it requires us to regulate the speed of the alternator, and to regulate the speed, it requires us to have a control action through the governor by which we can regulate the speed. Then governor sends the speed and gives command signal, steam input change relative to the load requirement. So almost all the parameters are related to control the voltage and the frequency. Most of the time, the control or regulation action is taken care at the time of generation itself. Though we have some sort of devices to control the voltage like capacitors, synchronous condenser, even reactors, and many devices, static var compensators we have in the system, which will help us to control the voltage as well, to regulate the voltage of the power system. So throughout the curriculum or the syllabus of power system operation and control, we will see all these controls in detail. Before to conclude, let us see relationship in between active power balance as well the frequency. So as already has been discussed in the prerequisite videos also and in this video also, so there is a strong relationship in between the active power, that is the load, and the frequency. As frequency is a common factor throughout the system, the change in the active power demand at one point is reflected throughout the system by a change in the frequency. So as all we know that we have interconnected system, we have many generators in the system. So all generators are connected all together to the common system, which is a grid system. So if there is any changes in the active power demand at one point in the system, that will be reflected throughout the system, as just because of it is interconnected system. And because of that, the frequency variation or changes in the frequency is applicable or reflected throughout the system. Because there are many generators supplying power into the system, some means must be provided to allocate change in the demand to the generators. A speed governor on each generating unit provides the primary speed control function, while supplementary control originating at a central control which allocates the generation. So the changes in the frequency will be taken care by speed governors, which are there in the generating units or generating stations. So if there is any increasing demand, or if load onto the system is going to increase, if we change the speed of the alternator with the help of speed governor mechanism, then we can generate more and more amount of power by which we can deliver required amount of active power to the load, and by which we can maintain the system frequency in the tolerable limits or rated values. So this can be done with the help of a speed governor. As all we have discussed, speed governors are located in the generating units, and the speed governor will provide a primary control to the frequency. For the supplementary or secondary control of the frequency, it needs us to control the parameters from the central station, or you can say load dispatch center, from where we are going to coordinate or control the generation. As well, we are going to allocate different units for different time periods throughout the day, by which we can control the frequency and we can deliver the amount of power required by the load. In an interconnected system with two or more independently controlled areas, in addition to control of frequency, The generation within each area has to be controlled so as to maintain the scheduled power interchange. So to have appropriate power exchange in between different interconnected areas, in each area there has to be an independent system. That is, in each regional area there has to be a system which will control the frequency in that region or in that area, by which it is very convenient to have a power exchange or interchange within the different regions. The control of generation and frequency is commonly referred as a load frequency control, that is LFC. So load and frequency, these are strongly dependent terms. So whenever there is a increase in load demand, then frequency might get reduced or drop. So to maintain the frequency, it requires us to increase the generation, by which we can able to maintain the frequency. So this type of control scheme, that is load frequency control scheme, we will study in the next lecture. Thank you very much.